Thank you. I thank you for organize this conference to that I have possibility to take part on the session in memorial Professor Oleg Georgievich Smolyanov. And I want to say that in the last time Oleg Georgievich has interest in of theory of gravitation on problem of quantum gravitation, and I have many discussion with him by telephone of these problems, and and it interesting possibility of functional construction, some functional integrals to solve this problem of quantum gravitation theory, and this communication with Professor Smolyanov is very fruitful to me. And I here speak about Schwarzian integrals and in a measure. As I say, this my talk dedicated of memory of Professor Smolyanov. We derive the explicit form of the popular decomposition, polar composition, decomposition of the Wiener measure, and obtain the equation of connection, connecting a functional integral in a conformal quantum mechanics, and was in the Schwarzen Theory. In recent years, the Schwarzen Theory has become extremely popular. It is given by the action. Here, I is equal -1 divided sigma square integral of circle with C is Schwarzian form, Schwarzian derivation of phi of t and plus 2 p square phi prime of t in square dt, where C phi of t is equal third derivation of phi of t divided first derivation, and from this function we take also derivation minus 1 divided 2 of third derivation of phi of t divided first derivation in square. This is a Schwarzian derivation. And phi of t is an orientation preserving diffeomorphism. That means that phi prime of phi of t is positive of the diffeomorphism of the unit circle. We write the such diffeomorphism diff1 plus of the circle. The Schwarzian action appears to be the effective action on quantum mechanic models of measuring fermions with the random interaction such the Kitaev model. In the holographic description of the Jacob Tetelbaum dileton gravity in open string theory and some other models. An extraordinary universality of the Schwarzian action is a consequence of its SL to R invariance. At the same time, the Schwarzen theory is not the only SL to R invariant action. This symmetry manifests itself in the conformal quantum mechanics, Liouville quantum mechanics, and some other models that are used to describe in the near horizon geometry, Reisner, Nord Stream black hole, and S2 CFT1 duality. Gravity near space-like singularity and our physical problem where universe region is reached. Therefore, the attempts to connect in some way the Schwarzen theory to our conformal invariance quantum mechanics model are quite natural. Here, to connect theories with each other, we propose to study the corresponding functional integration measures. We consider the measure mu sigma Schwarzen action is here. It takes here 1 divided sigma square integral from 0 to 1 Schwarzian of function of t dt and integration dphi. On the group of diffeomorphism ones plus of circle, and so it's possible to consider next measure on the diffeomorphism on the interval 1, 0. This measure is here mu sigma the phi is equal 1 divided the square root of derivation of phi of 0 multiplied on derivation phi of 0.1. And when the exponent of 1 divided sigma square integral from 0 to 1 Schwarzian of phi in point t dt and plus 1 divided sigma square phi second derivation in 0 divided second 1 derivation of 0 and minus as such function in point f1. This is measure on the group of diffeomorphism of interval 1 to 0. The measure can be generated from the Wiener measure and some special substitution of variables. Namely, let us consider the function xc is a continuous function of interval 1, 0 that satisfying the boundary condition C of 0 equal to 0. And then under the substitution, phi of t equal integral of 0 to t exponent xi of t, xi of tau de tau, divided of integral 1 to 0 to 1 of exponent xi это d. Xi of t equal logarithm of derivation of function phi of t minus logarithm derivation function phi of a point in 0. The measure mu sigma d phi is on the group of diffeomorphism diffeomorphism 1 plus of interval turn into the Wiener measure of W sigma dxc on the space of continuous function C0 of interval 0, 1. The measure are quasi-invariants of under the action of the subgroup consisted of 3 times the derivation transformational group subgroup of diff 3 plus of interval of d plus of circle of if we consider the measure on the circle, or we consider the measure on the interval, the action we consider diff 3 0 of interval closed interval of 0, 1. Quasi invariance means that we under action the subgroup G. In these cases, we consider if we take measure on diff of circle, consider diff 3 of circle on interval, also diff 3 on interval. The measure mu sigma transformation to itself multiplied by function of Rg of H, parameterized by element of the subgroup of G elements subgroup G from group grand G. Mu the G convolution of H is equal to the function that is Radon-Nikodym derivation of this measure divided measure initial the function R mu G H mu DH. Using the quasi-invariance of the measure mu sigma d phi, we have evaluated functional integral for the partition function and the correlation function in the Schwarzen theory explicitly, and derive the general rules of functional integral in the theory of Schwarzian type. A Wiener measure on the infinite dimensional spaces continuously positive functions of C plus of interval 0, 1 is also known to be quasi-invariance under the action D3 plus of 0, 1. We find that two measure connection with each other by the equation. Within the measure, the sigma dx is equal exponents of sigma square minus sigma square divided 8 rho square, and this is multiplied of phi prime 0, phi prime 1 in power 3 divided 4, and this multiplied of measure mu sigma 2 sigma divided rho the phi the rho. Here x is element of the space C plus 0, 1. That means he is a continuous function on interval of 0, 1, a positive continuous function. And phi is a diffeomorphism of group diff 1 plus of interval 0, 1, and rho is a positive a positive value, which is this equation we named polar decomposition of the Wiener measure. The corresponding polar decomposition of the measure on the circle has the next form. W sigma dx is equal exponent of minus sigma square divided for rho square and multiplied measure mu 2 sigma divided rho the rho. Here x is element of space C plus of circle, and phi is diffeomorphism 1 diff 1 plus of circle, and rho also a positive value. Stratification of the space C plus 0, 1 and polar decomposition of Wiener measure. We can write the Wiener measure W sigma of dx is equal minus 1 divided 2 sigma, and integral of 0 to 1 x prime of t square dt dx. And the measure and the measure is quasi-invariant under the following action of group of diffeomorphism D3 on a continuous positive function on of 0, 1. If we take F is the diffeomorphism of such group, and X is a positive continuous function, we have action F on X. Here, F of X result in point of t equals X of inverse of F of t, is divided on square square root of inverse of f of t derivation. And this is the invariant under the space is invariant under the action of the group of diff of 0, 1. It is gives the invariant of of this action gives by next integral. One derived rho square is equal to integral 1 to 0 one divided of x of t in square dt, as this integral is invariance of the action of diff 3. And defined phi of diff 1 of element of group of diff 1 plus of interval by the action inverse of phi of inverse of function on phi in a point of t is equal rho square and multiplied on integral 0 to t 1 divided x square of t dt. And x of t is expressed in terms of rho of and phi by these formulas here of formulas of 10. With, in this case, we have next formulas. Integral of 0 to t of x of t in square dt is equal to rho square and integral of 0 to t p prime of t in square dt. Therefore, this and 1-to-1 correspondence of rho phi and x and the space of C plus of interval 0 to t is stratified by orbits different value to invariant of rho. For the smooth x and 3 times differentiable phi of t, phi belongs of a group of D3 plus of interval 0, 1. We have obtained next formulas. Here is right. First, for the Wiener measure on the space of C of P, the following polar polar decomposition is valid. This gives by formulas here. And the normalization factor, function of rho, to be evaluated below, determined by realization weight of the input to the measure from the path of x of t with the definition value 1 derived to rho square on invariance. The normalization factor is polar decomposition of Wiener measure to find explicit form of the density of rho of grand rho of rho. We multiplied by 2 delta function and consider the following equation. Sorry. We find the next equation here. First, the evaluation of the function integral in right hand, it can be rated as rho sigma of rho time, and here the integral of from the measure mu sigma to sigma rho, the rho here is a delta function. After the substitution, the equation of 15th takes the next form written here in by 16th, and evaluated the integral. We differentiated the equation writing the formulas of 17. Here is possible to this with it's here the Wiener measure and integral of the delta function xi of delta and xi of t, and exponent from next function. It's and we have exact values of these integrals written here by these exponents. Also, we used the equation, the next, and it is represented in the form. Here is in this equation of functional of rho, and next equation here, the integral of by Wiener measure. And these integrals is possible to find, and we find the next integrals of Wiener measure. This integral is equal by next equal to such is possible to write by functional integrals. It's here the formulas 19. We're scaling also the parameter rho and lambda. We find such integrals. The integral of space over C plus of interval of 0, 1 is nothing less than trace of exponents of operator minus operator A0 and this is a functional integral of partition, a function of Colagera model by given Euclidean action. written in formulas 21. Also, we imagine a couple constant. G is equal I lambda. Note that the appearance of the action of conformal quantum mechanics is tightly connected to reduction of Wiener measure to the orbits. Since the action is a continuous spectrum, we first consider the regularization action. Is the regularization action here written in the formulas 22. Calculated the Fourier transformation written here by formulas 23 and tends to parameter sigma to 0. The solution of the quantum problem for the action of quantum oscillator with the square inverse potential is well known. The wave engine function psi of x, psi of 0 is equal to 0 from in basis of Gilbert space and a square integral of the semi axis x positive axis function for with the energy level here this energy level, and therefore a partition function of action equals to this integral left equal to trace of operator A-N. And it's possible to find, and is equal to exponent of such value divided on 2 hyperbolic signum of on. And the integral over lambda has the next form given to formulas 25. After substitution, such substitution divided the integral to parts, and is possible to find this integral. And finally, we find the function rho sigma to rho is equal to exponent minus sigma square divided for rho square. Thus, we proved the polar decomposition of the Wiener measure presented by formulas 27. These formulas gives us also to find the polar decomposition of Wiener measure on the circle. These formulas give us 24. I say about this. And now consider connection between the functional integral in Schwarzen theory and the conformal quantum mechanics. From the polar decomposition of Wiener measure, we have the equation of the functional integral. This functional integral is interesting in conformal quantum mechanics. Here, integral on the space C plus of circle f of x, and exponent here is minus 1 divided to sigma square, and integral on the circle x prime of t square minus 2p square x of t square minus plus 2 divided to g divided x of t square, and in the t and the x. Bipolar decomposition, we hear that this integral function, this half integral equals next integral of 0 to plus the infinite, the row of exponents minus sigma sigma divided 4 plus g divided sigma square with multiplied 1 divided rho square, and multiplied on integral of different on the group of different is 1 plus of circle from the function f of x of rho phi, and exponent of Schwarzian action. The parameterized by rho square divided 4 sigma square. In particular, for f of x equal phi of x and exponents of minus beta square divided sigma square of integral on the circle of x of t squared t with phi of t good enough, the integral are well defined. Therefore, we have a transparent connection between conformal quantum mechanics and the Schwarzen theory. If the function phi is SL to R invariant, then it can be reduced to the orbits. In these cases, the integral can be factorization with the result. Here by next formulas. This formula says 30. Evaluated functional integral and conformal quantum mechanics, we thus find corresponding functional integral in Schwarzen theory, and vice versa. The technique of functional integration on the group of difference make it possible to evaluate it non-trivial functional integral in conformal quantum mechanics. Consider a sample example. Let us put g equal 0, sigma equal 1, and taken phi of x equal delta. This is delta function of p square minus 4 integral of circle dt divided of x of t square. the right-hand side defined the partition function in the Schwarzen theory, Z Schwarzian of K. This is equal integral. This is equal 1 divided square root of 2 p and p and integral of exponent of minus e, this is Schwarzian action, the phi, and integration we taken group of diff 1 plus of circle divided SL to divided of subgroup of SL2F. The left hand side leads to the result this function of z of t is equal 1 divided of the square root of 2p and t in the cubic. And multiplied of exponents of 2p squared divided p squared. We obtained earlier by a derivative functional integral in Schwarzen theory. An example of application of polar decomposition in conformal quantum mechanics. We use the exact solution of the quantum oscillator model with Colagera potential to evaluate the functional integral assigning to partition function in the Schwarzian theory. The polar decomposition of the Wiener measure can be also used in the opposite direction. Namely, we can use already evaluation functional integral in Schwarzen theory to perform non-trivial functional integration in conformal quantum mechanics. In this way, we find the fundamental solution of the Schrödinger equation in imaginary time in the quantum mechanics models with Colagera type potential. Consider now the heat transformation, transfer equation of the form T of phi of G of Q of tau is equal 1 divided 2 the square divided the Q square minus G divided Q square multiplied on function of C of G, Q of tau. Here Q is positive. It is a Schrödinger equation, and in imaginary time with the potential where Q equal G divided Q square. The excluding a path of a negative value of x of tau in the subsequent functional integral, we put the boundary condition Cg of 0 of tau is equal 0 and integrated over the space C plus of 0 t. let the initial condition by C of J of Q0 is equal C0 of Q that equal delta function Q minus Q0. Yeah, Q0 is also positive. The fundamental solution of Cauchy problem is given by functional integral written here. The formula is 32. After substitution of tau is tau, tau, y tau is x of tau, tau, tau is now equal, tau is point of interval of 0, 1. It turns to next equation by formulas 33. Here is Wiener measure with dispersion 1.
I must notify you that the basic time for speech has finished. If you need some more time, okay, we will provide it. But
I have 2 minutes. 2 minutes.
Yes, this will mean that just only will have less time for questions. No problem. Okay, please continue.
And we write these formulas by transformation of polar decomposition here, and it's possible to find these integrals. All this needs the we find next function E sigma U by formulas given by 37. This by this function is by these integrals, and finished we find the solution of this problem by formulas 24. Here find this solution here, and it gives the solution by polar decomposition. And if we interested in taken G equal 0, if we find next here we find after some calculation we find the result well known by given by formula 44. This talks based on the next based on with these two papers that results is in collaboration of Professor Belakov. And also in finished I want to say that Professor Smolyanov is interested in these problems and gives we have many discussion about this problem with Professor Smolyanov. Thank you for your attention.
Professor Shavgulidze. questions, please.
Evgeni Tengisovich, is it possible to extend your theory, your approach from the one-dimensional circle and its diffeomorphism to finite dimensional torus or spheres and its diffeomorphisms?
Well, it's a very interesting question. And I want to say to the quasi, sorry, the quasi-invariant measures also possible analog of measure quasi-invariant by Schwarzian action is possible analog action have on torus and sphere and so on. And in this problem we're interested now. I think that it's possible to find new results.
Thank you. Thank you.
More questions, please.
I have a question, Albeverio.
No, well,
I don't know, do you hear me?
yeah, I hear.
I want first to congratulate Professor Evgeni Shavgulidze for a beautiful work he presented.
Thank you.
And I had actually a related question to the one which was just posed a moment ago. So, but I just a side remark, that if you, I mean, in the theory of just, so to say, quantum mechanics, but in the formulation for quantum fields, so that you have the problem on the full line, not on an interval, but on the full line, and you have the interaction. Usually it is maybe some power, but you have harmonic oscillator plus 1 over x squared. That model has been worked upon by Professor Zbigniew Haber from Poland.
Yes.
And probably you know this work, but my question is only to mention whether there is some relation, and especially then to so to say other manifolds, even in
this is with this potential is a very known result. Yeah. But I right, but it's possible new method by polar decomposition to find.
Yeah. No, that's very interesting.
Only this is a very well known result, conformal quantum mechanics.
Yeah. Right. Thank you very much. Congratulations again. Thank you.
Thank you.
More questions, please.
Recording stopped.